Hello, everyone. Welcome to the third session of our Cloud Native Launchpad series. If you missed the first two sessions, you can find the recordings on our Devon and Beyond Cloud Native Launchpad page. Our topic today is managing code. We'll talk about various tools available in Oracle Cloud Infrastructure to streamline your code management efforts. My name is Renu Bhatt, Program Lead for the Customer Enablement team here at Oracle. And our presenters for today are Eli Schilling and Lynn Lewis. And now I'll hand it over to Eli.
Excellent. Thanks, Renu. And welcome, everyone. This is our Managing Code and Associated Resources session. Before we get started, we'll do just a couple of quick intros here. So my name is Eli Schilling. I'm a developer advocate here at Oracle. I spent the last 10 years or so in the cloud space between Oracle and a few of the other providers out there, working predominantly in the developer space and working with DevOps and related tools. And I'm joined by my colleague, Lynn. I'm going to give a quick intro, sir.
Yes, thank you, Eli. I'm Lynn Lewis. I'm a senior cloud engineer here at Oracle. I've been at Oracle for 8 years, the entire time in OCI.
Excellent.
Turn it back to you.
Great session lineup today. As Renu mentioned, we've done 2 sessions so far in the series. You can find those online to view the recordings. Today, we are going to be diving into the Managing Code session. So you are here on the map. Thanks for joining us. And just so everyone's aware what we have coming up, the next session will be Kubernetes Management Made Easy with our Oracle Container Engine for Kubernetes. We're then going to jaunt across the ocean there and dive into serverless apps with the OCI Function Service. And we will face the final boss when we talk about building and enhancing your CI/CD architecture with OCI DevOps in our 6th session of the series. So hopefully you'll join us for those. So for the session today, we're going to discuss the importance and the value of source code management. I'm sure most folks are pretty well familiar with that, but it's always fun to recap. We're going to simplify access to cloud resources with our OCI Cloud Shell tool. We'll talk about some of the common development environments, including those that are available right in the OCI web console. And then we'll talk about creating, storing, executing code in the Oracle Cloud with these tools. So without further ado, welcome to source code management. Now, just some of the basics here for those that might be new to the developer space. Source code management is really all about controlling access to and maintaining consistency of our application and even automation source code, which we can talk about a little bit. We're going to start by picking our favorite development environment. That could be a tool you install on your laptop. There's some SaaS tools out there that we'll mention briefly. And of course, the one we'll look at today, which is OCI Code Editor. We'll use those to write and maintain all of our code that we are then going to push into the source code management tool of our choice, whether that's the OCI Code Repository or another third-party tool that's available out there on the internet. Of course, you can also install any sort of Git server. If you need private or additional layers of governance, you can install and manage those source code tools internally inside your environment and protect them and block them away from the public internet. Now, when it comes to delivering that code, it kind of depends on how you're going to package, whether we're using something like Java or Node that needs to be compiled, or something like Python that we're just going to use an interpreter for to execute the code in line. And I did mention, automation tools. So we did just talk about infrastructure as code in our last session. And as the name would imply, it is also source code. So we want to make sure that we manage that resource or those resources the same way we would our own application code to ensure consistency, auditability, and make sure that we are able to see what has been changed, who made those changes, just to make sure that the code is functional and consistent and hopefully devoid of any unexpected errors. Now you see at the bottom of the screen there, the Oracle Cloud Shell. We're going to include that in the conversation today because it's a great tool for not only interacting with our source code management tools, but also other automation capabilities inside of the Oracle Cloud ecosystem. Now, some of you might be thinking we're missing a piece, and you'd be absolutely correct. The continuous integration and delivery capabilities that would be found in a DevOps tool We will certainly be diving deeper into that, as I mentioned, in our 6th session for the series. So hopefully you'll come back and join us for that. But that is a critical component that helps sort of tie this all together and add a layer of automation to our source code management capabilities. So with that, let's take a quick cursory view of some of those options that are out there. We're going to start, obviously, with the OCI code repo. This is part of the OCI DevOps service. And as you might expect, in this case, it is a Git-compliant source control tool. It supports mirroring with external code repositories, so it makes it really easy. If you're already working on a project with, say, GitHub or GitLab or Bitbucket or something else out there, you can set up an external connection and mirror that repo into the OCI DevOps service to more easily expedite your efforts to work with that code inside of OCI. You can even lock down access based on IP addresses. So if you're working with a team in an office or in a particular location, you can actually define basically whitelist IP addresses that are limited for access to that repository. And as a benefit of being part of the OCI ecosystem, it's tightly integrated with the DevOps toolchain. So simplifying the interaction of storing code, collecting, building, and delivering that code to other services within OCI. Now, GitLab, many folks may be familiar with this and possibly already using it. It is an internet-based, call it SaaS type service that's available. Built-in tools like their own DevOps service for continuous integration and delivery, and tools like code reviews and code quality. Also being able to scan for security vulnerabilities in your code. And of course, given the nature of the tool, there are free and paid options available. Last one we'll cover really quick, GitHub. Again, because you can link your OCI DevOps code repos to both of these external source control or source code tools. GitHub is also a very popular tool that many folks may already be using. It includes automation capabilities like GitHub Actions. It has built-in CI/CD automation. There is a Codespaces cloud development environment. If you haven't checked it out, it's pretty slick. So kind of like what we'll look at in an OCI code editor, it's another web-based tool for writing and editing code. And of course, free and paid options available there. Now, before I move on, just a really quick, trip down memory lane. It's kind of funny. I would say 20 some odd years ago, when I had one of my first development jobs way back in the day. And Lynn, you may be familiar with this as well, but came onto a team that was doing some simple web development, and I asked for access to the source code system. And I got kind of a funny look from some of my teammates, and they said, "Oh, we just store that code out in a file on a shared folder on the network drive." And so I went out there and took a look at it, and this was, back before really even good version control from a file system perspective was available. So there was no version control, no audit capabilities. It was just a whole bunch of text files with code, and they were often being overwritten, and that caused a lot of issues. So we did some digging and wound up implementing Visual Source Safe. So for those that may have heard the term many, many years ago, that was one of the first source code management tools that I got to work with. It's kind of fun. How about you, Lynn?
My first experiences were in a government laboratory with Fortran that was run primarily on workstations or on crays. There were nothing in between. And it was very much like the cloud in the sense that we would have the cray, of course, would be remote, and we'd dial it up. So we do a lot of the code work locally and then move it up as we needed. We kept separate directories for each creator, and we each had a piece of the code that we would work responsible for. So each of us had our own methodology for maintaining source code. So but I've also worked with professional software developers in Europe and in the States. And in those times, they started off with commercial products. There was a number of commercial products before GitHub and GitLab that would do the source control.
Yeah, it's kind of funny to think back on those days. It's, kind of a free-for-all, everyone doing their own thing, and limited oversight, limited consistency. think we've definitely come a long way, and it's nice to see where we are today versus back in I call it the dark ages of development almost. All right. So let's take just a quick minute and chat about the OCI code repositories. This is going to be, as I mentioned, a fully functional source code system if you choose to utilize that for storing and managing your source code. But of course, you don't always have to start over or move everything over. If you're already using something like GitHub or GitLab or even Bitbucket, it's easy enough just to link up to those existing repos, and you can mirror that code into the OCI DevOps service to make it simpler to interact with your various cloud-based projects. Now, we'll take a look at mirroring in just a minute, but it does make it easier to synchronize the code between external and OCI repos. And just, like the other source code tools out there, you can authenticate with SSH, which requires an API signing key, or you can use HTTPS authentication, which leverages a token, kind of like the personal authentication tokens you might find in GitHub. I mentioned mirroring repos. So this is a really great way, again, to synchronize an existing external repo, clone that code into the OCI code repository service, and then maintain consistency. So you get to define your own synchronization schedule, whether you just want to do it once and start working a new project with that existing code, or if you want to keep the repositories in sync to make sure that you always have the latest version of code between your different source code management tools.
Now, in this demo, we are going to create an external connection out to an existing GitHub repository, and then we're going to use the OCI DevOps functionality to mirror that repository into the OCI code repo service. Now, part of that, there's a few things to keep in mind here. We are going to generate a personal authentication token on the GitHub side. We need to store that in a secure fashion, so we're going to create an OCI Vault secret, and we're going to drop that PAT into OCI Vault so it's encrypted and stored securely. And we need to create the external connection and utilize that Vault secret in order to authenticate into GitHub. So we're going to create an IAM dynamic group, and basically what the dynamic group does is incorporate the OCI services we specify, which in this case, it's going to allow the DevOps connections, or the external connection feature, to access that secret from OCI Vault. That access is done through an IAM policy that basically says this dynamic group is allowed to use the secrets in the specified OCI compartment. Once that process is complete and my external connection is set up, when I establish the mirroring process, we're basically going to go out to GitHub, select the appropriate repository, and then we're going to mirror that repository into an OCI code repo. So with that, let's jump into the OCI console and take a look at how this is going to work. So here we are on the OCI console. We've already logged in. We're in the Developer Services DevOps projects, and I have a project here called Core Dev Work. The first thing we want to do is create our external connection. Let's call this my GitHub repos. I can give it an optional description. For now, we'll just leave that blank. The type here is GitHub, and we need to pick the vault, which here is example, and then the secret that I've stored in the vault that contains my personal authentication token from GitHub. We will create that external connection, and we're going to come back to our project, navigate to code repositories. You'll see I have a couple I've already created here, but in this instance I have an existing repo that I'd like to mirror. So we're going to pick our external connection we just created, and it's going to load a list of repositories that I have access to on GitHub with that PAT. So you'll see I have quite a long list. I have access to things like the Oracle code samples, Oracle DevRel, another great resource. We have several hundred repos there with sample applications and sample code and things of that nature, all the way down to my own GitHub org, where I have my my functions, my FN demo app that I want to do. Now in this case, again, we can specify just mirror once, copy that code over, or I can set a default, which is every 15 minutes, or I can customize that mirroring schedule to be, you know, every minute, every hour, or so on. For this, we'll just do default. We'll give it a name indicating it's coming from GitHub. The repo is FN demo, and we'll go ahead and mirror. So with that, the work request is submitted. It will take just a minute or so to complete the task, and we're all set. So the handful of sample files have come over. You can see here, in this case, I just have the one branch. There's 4 files, and you can view the markdown for my hello world, my README markdown file. I can take a look at the files themselves, commits, I can compare, look at branches, perform tagging. Everything I'd expect to see in a Git repository. So there you have it. Let's go ahead and jump back into the next section of our presentation.
All right, so moving forward, we're going to take a look at the OCI Cloud Shell. This is going to be a really nifty tool that gives us an added layer of functionality to not only interact with OCI services, but also with our source code. So the Cloud Shell is a browser-based terminal. Looks a lot like a Bash shell or Linux shell. And it basically becomes persistent in the browser when you launch it. We'll jump out there here in just a minute and take a look. But the nice thing is this is a customized image that OCI manages and maintains for you. And it comes pre-installed with a whole bunch of really nifty tools like the OCI command line interface, Ansible and Terraform for infrastructure automation and config management. Has Git built in, it has Java, Python, and a whole host of tools that are pre-installed and maintained as new versions are released to make it easy just to jump right in and get started and get your work done. The authentication for the Cloud Shell is basically a delegation token. So when you log into your browser, we create an authentication token. It's shared with the Cloud Shell, so it's tied directly to your user profile. That makes it easy. Again, you don't have to re-log in at the CLI or at the Cloud Shell. You just open the Cloud Shell and go straight to work. This does include 5 gigs of storage, so it's automatically backed up on a regular basis, and we maintain that for 6 months. What that means is if you log in, create some stuff, and you go away for 6 months, you travel the world, you don't log into your account, we're going to send you a note at 6 months that says, hey, we've missed you. We've got some storage we're holding on to for you. If you still want it, please just log back in the next 30 days, and that clock resets. So you won't lose any of that work as long as you log in twice a year, basically. Another thing about Cloud Shell that's cool is the default access is public internet, which means once I'm connected, I can access public source code repositories. I can access public services and APIs and things of that nature. But if I'm working on a particular project, there's an ephemeral private network access that's available, and we'll demo that here in just a minute. But that allows you to basically connect into your own virtual cloud network in order to interact with private network resources directly from the Cloud Shell. So it becomes isolated away from the internet. It basically becomes a temporary resource inside that network for you to use to communicate with or make configuration changes on your resources, your hosts, your databases that might be in that private dedicated network. And last but not least, there's a upload-download option, so you can easily get files to or from the Cloud Shell without having to leverage tools like SCP or FTP, things of that nature. You can just upload, download, and the job is done.
Now let's go ahead and jump out to the OCI console and take a quick look at our Cloud Shell. You'll see we land right here on the home page, and the Cloud Shell is accessible from the Tools menu up here in the top right corner. And you'll notice no matter where I go in the OCI console, that is always going to be there. So really quick and simple way, just pop that open, hit Cloud Shell, and it'll take just a moment to open that up. All right, so before we jump into the Cloud Shell, and start running some test commands here. I just wanted to show that the Cloud Shell here is persistent. So no matter where I go, however I navigate through different consoles and different services, it remains here. It remains active. I can, of course, minimize the Cloud Shell. I can restore it, and I can also make it the entirety of my browser window. Now, I mentioned earlier that we can make this, or this by default is a public network, but we also have the option to set up an ephemeral private network. And this basically allows us to pick from any one of our existing VCNs, virtual cloud networks, in our environment, and we can pick a subnet. So once I pick the subnet, generally it's a private subnet, or maybe a public subnet that's been configured for Bastion-style access and is able to reach other resources in the private subnets. It's basically going to create a temporary tunnel between this Cloud Shell session and that private network segment. And this will enable me to, so long as I have the right ports open on my security lists or network security groups, I'll be able to connect to my private resources from Cloud Shell, be it SSH on port 22, or maybe SQL Server or Oracle database or whatever I might be trying to connect to, as long as I have those ports open in my security list rules. If there's certain networks you use quite frequently, you can actually set up a list. There's the private network definition list, and this just allows me to create up to 5 favorites that are saved here, and I would simply come in here, use as my active network, and it will switch my network interface over to this resource that I've previously configured. Again, you'll see if I run this as a really simple command to list, let's say list my availability domains in the current region, I can run my command, and it is authenticating using the delegation token that I mentioned with the user I've logged into my cloud account with here in the web console. If I want to check to see what other tools are installed, Python, we've got Node.js, there's a whole host about Terraform. So you can see that all those resources are available in my Cloud Shell. So they're loaded up and ready to go. All right, so that's just a quick intro to the Cloud Shell. Let's jump back into the presentation, and we'll be back here in the Cloud Shell before you know it.
And just a friendly reminder, Oracle Cloud Infrastructure is now available in 48 regions worldwide. And your Cloud Shell, your code editor, your data is accessible wherever you want it to be. So if I need to connect to resources in, let's say Paris, I can either access those APIs over the public internet from my home region, which in my case is Phoenix, or I can actually change my profile, redirect my user console out to Paris, and then interact with those resources locally. One little tip, I mentioned that the Cloud Shell, the 5 gigs of storage is backed up to a fault-tolerant and highly redundant storage system, but that is what it is. It's just a backup. So typically what I try to do is, any directory that I create, I store, I'm basically just cloning a Git repo in order to make sure any files that I create in the Cloud Shell are also maintained in a source code management system. But sometimes I get carried away and I create, helper scripts and things that I want to use outside of any sort of source code project. And so what I did for myself is I set up Git at the root of my Cloud Shell home directory, and of course leveraging things like git ignore to not pay attention to my actual development projects. It just makes sure that I can commit and I can push those one-off files out to source control, just to make sure I don't lose anything, or maybe overwrite a file accidentally or delete a file. That's really just a personal preference, but yeah, it's a great way to just make sure all of that content that you're creating in the Cloud Shell is also stored in a version control system. So I mentioned that the Cloud Shell uses a delegation token, which essentially is based on the user that you've logged into your web console with. But the nice thing is with OCI, you have the flexibility to authenticate in a variety of methods. And with tools like the OCI CLI, you can create additional config profiles. And those config profiles can be based off of things like an API key. So even though I've logged into the console as my primary user, I've activated Cloud Shell, which then gains the same permissions. As a developer, I like to test things. So maybe I've set up some additional OCI users that have limited permissions, or maybe project-specific permissions. So if I simply create additional API keys for each of those users, I can go into Cloud Shell and create a config profile that utilizes that alternate user and that alternate set of credentials. And the simple part here is I basically execute the commands that I'm looking to complete. And then I specify which config file has those profiles. What is the name of the profile that I'm looking to use? So which is the alternate identity that I've selected for this particular task. And then specify the authorization type of API key. And now I can authenticate that particular command using a different set of credentials that will supersede what's set up by default in the Cloud Shell. So a lot of flexibility there, and it allows me really to experiment with different configurations, different application components, different pieces of infrastructure. Makes my life a whole lot easier.
So here we are in the Cloud Shell again. Let's just take a quick look at the existing environment variables that are automatically set. And to do that, we could just do an echo OCI double tab. And it's going to basically show us we have OCI auth type, CLI auth, config files, etc. So if we want to look at a couple of these, let's just do CLI config file. We'll find the default is that etc OCI config. If we take a look at, let's say something like OCI CLI profile, the profile is going to be the current region, which is Phoenix. Now, a really quick trick. There's two ways we can interact from here with a different region. Option one is I can run OCI IAM availability. I don't know if I could type properly. All right, so this command is going to basically run the list off of availability domains, and it's going to target the Ashburn API endpoints. So provided I've subscribed to the region and I have access to the region with my logged in user, you'll see that the command is executed against the regional endpoints in Ashburn, returning data about the Ashburn region. Now the other option is to simply change the region. So from here I could move over to Ashburn. But keep in mind that the variables are loaded only when the Cloud Shell starts up. So even though I've now moved my browser console or my web console over to Ashburn, I would need to restart Cloud Shell in order for this to take effect. So we'll simply exit. We'll relaunch that. It's usually pretty quick. Now the cool thing is it's going to store my history. So you can see the last command I ran was listing availability domains in Ashburn. But I can also echo the profile again, which you'll notice is changed to Ashburn. So because I launched the Cloud Shell while attached to the Ashburn region, it automatically sets that default profile to be Ashburn. So now any command I run is going to be automatically targeting the local regional API endpoints, which in this case is Ashburn. Now we took a look at the notion of potentially authenticating with non-delegation tokens. In this instance, let's say I've set up an IAM user and I want to be able to use, so let's say I've set up an IAM user and I'd like to use those credentials for testing purposes. So in this case, I've created the user, I've added them to a group, assigned some policy statements so they have permissions to do things, and I've provisioned an API signing key for that user. Next thing I'm going to do is run OCI setup config. And this is simply going to take me through the process of configuring or creating a config file for my CLI. Now you'll notice it's going to put it in my home directory in a hidden folder called OCI, and the file name is just called config. This is going to ask you for your user OCI ID, your tenancy OCI ID, the location of the existing API signing key if you have one. If not, it will create one for you. If you do allow this process to create a new API signing key for you, you do have to take the public half of that key and attach it to the IAM user for which it's intended. So all of that is included in the documentation that you can see right up above on the link here. I've already gone through this process. We're just going to go ahead and skip. And if we cat that file, you'll see here that I have a user account, a location for the key file, a tenancy, and then the default region for my requests. Simple enough. We're going to run the OCI IAM availability domain list. And as we saw in the slide, we're going to tell it where the config file is that we want to use. Which profile in the config file to use, and the auth type, which in this case is API key. So pretty much the same output, but again, this time the command was executed using a separate set of credentials that, if I'd wanted to, could be locked down to not be able to run this type of command or other more sensitive activities inside of my account. So there you have it, a really quick and easy way to experiment inside the Cloud Shell with different types of authentication. And now, back to our regularly scheduled programming.
Now, what about Cloud Shell and Code Editor? So I've talked about Code Editor, and they're essentially two like-minded tools that share an underlying file system. That is, anything I create, alter, or move around within the Cloud Shell, it's obviously my home directory in that particular container. Cloud Shell or Code Editor is going to access those same resources. So if I wanted to use a virtual editor as opposed to something like Vim, I could simply open my Code Editor tool, point it at the directory where the files live that I want to work with, and I can begin to pop those up into a familiar code editing tool and work with them right there. So let's jump into our IDE CDE discussion here. And Code Editor itself, this is it's an in-console IDE tool. Some of you who may have used things like VS Code might be familiar with the look and feel. But the nice thing here is it supports direct integration with a handful of OCI services like Functions and Resource Manager for infrastructure as code. And if you're a data scientist, you can use the data science plugin for modifying your notebooks and running data science jobs without having to go out to the data science console directly. So if I'm modifying code, I don't have to be bouncing back and forth between my Python code, my notebooks, and then switch to a different UI and test things. I can do it all in a single pane of glass. It's also linked into Git. So from right here, I can modify my files. I can run a commit. I can push that code up to my Git repository. I can branch, I can fork, I can check out. And all of that's done right inside the Code Editor user interface. Another cool thing here is my code is auto-saved. So I don't have to think about hitting the Control-S key every so often or Command-S, depending upon which brand of laptop you have. It just automatically picks up those changes as I make them. And again, it's synced to the file system that is used by Code Editor and by Cloud Shell. So I can kind of bounce back and forth. And if I change something in Code Editor, go back to the Cloud Shell to run a script or an automated command, those files are updated and of the right version. Another cool thing within Code Editor, you have, like you would with a tool like VS Code, you have the terminal feature built in. So I can also incorporate that to run different tests that I might be running over in Cloud Shell, or maybe I just don't even want to run Cloud Shell today. I'm going to open Code Editor, I'm going to launch a terminal session, and I can do all my work right there in a single spot.
So let's head out to the console once more. And we're going to go back to that menu in the top right corner and simply click Code Editor. Now you'll notice that it does make the interface here full browser size, but we are still able to navigate between Cloud Shell and Code Editor at the same time. You can also change the view by whether they're stacked or side by side. So a couple things about Code Editor just to get started here. You'll see we have our file system, we have our search option, our Git integration, and then we have our Oracle or OCI plugins that we can work with. So also I can go and I can start a new terminal if I wanted to from here. So if we're working with, Node.js, or you're working with Python or something you want to be able to test right here in the IDE, that is accessible with the terminal. Now, just to get started, let's go back to our Cloud Shell here. And I do want to go into one of my folders here. All right, so for here, we're just going to go into an existing folder that has some content we'll be working with. And that's in my pubgit folder /fn project. Take a quick look, you'll see I have some Terraform files and a subfolder for functions, which has some Python code for my sample function, and then the requirements.txt, which defines which additional modules to install when that function is built. But we'll come back to that, because what I want to do now is jump into the code editor. And if we recall the pubgit /fn project folder, I can go ahead and navigate to my home directory here. You'll notice I have the pubgit fn project folder, and here are all of my Terraform resources. Take just a quick look. It's going to pop open a nice color-coded editor for the Terraform code. Alternatively, I can jump into the functions sample function directory, and let's take a look at the Python code for this sample function. It's pretty basic. We're just going to be importing IO, JSON, and logging, the functions development kit, and we're going to basically do a sample, hello world with a few additional context data that's going to come back from that. Now, you might notice these little X's that pop up under function.py. The primary thing here is in the Cloud Shell, it doesn't know how to handle this FTK. Don't worry about it. You can ignore that. It will run just fine when we actually build and deploy that function a little bit later. So it's pretty straightforward here. If we needed to make any changes to the code, let's say we wanted to remove the headers, for example, I could come into Cloud Shell. I could use VI to edit the function sample function .py, come down to that headers line, and then we're just going to save that. Now, the second I come back over to the code editor, you'll notice that headers line is gone. That's how quickly the UI here syncs with the underlying file system. So we'll just go ahead and put that back in for good measure. Don't press any buttons. You'll notice once I do that, it's essentially going to autosave, and the headers are right back there in the file. So again, you're working from the same underlying file system. It streamlines any effort, any activity between writing and managing code in your code editor and any underlying activities you might be working on in the Cloud Shell. All right, let's keep moving forward.
So just really quick, I won't run through all of these, but I mentioned the 4 services that are integrated into Code Editor. And it really makes it easy to interact with your resource manager. So your Terraform or infrastructure as code. I can modify that infrastructure, that Terraform code right there in Code Editor, and I can apply those changes directly to an existing resource manager stack. So I don't have to go download the config, modify it locally, and then re-upload it back to Resource Manager. I can do all of those things right through the Code Editor interface. Similar with OCI functions, I do have to create an app, which is kind of the overarching container for all of my serverless functions. But within that app, once it exists, Code Editor has the ability to edit You can create new functions, you can deploy those functions, invoke those functions for testing purposes, modify the settings if you need more or less memory per function. So it kind of simplifies the process there. And then you'll see for data science and for data flow, there's a whole set of features available. Once again, do all that work right through the code editor interface, as opposed to having to bounce back and forth between the service console and your IDE. So let's start with a quick demo of using a resource manager and code editor together. Here, we're basically going to go grab some Terraform code. We're going to first create a stack. And then once that stack is up and running, I can pull that code into the code editor, make some changes to it, and apply those changes to deploy some additional infrastructure as part of that existing stack. So let's jump over to the console and we'll take a look at that here for just a few minutes.
So as we jump into the console here, you'll see I have a resource manager stack that we previously deployed. And we'll take a quick look at the logs here. So it's a basic function. We're going to create a Docker image, push it out to the OCI container registry, and at the very end, we are going to invoke this function. Pretty straightforward stuff. Instead of hello world, this is hello to our cloud coaching audience. So we'll jump into the code editor here. And let's just take a look at my integrations. We're going to come into the resource manager section and navigate down to my compartment, my stacks, and this cloud coaching example stack. Now you'll see here, I have all of the source available for this, so I can modify the Terraform, I can modify the underlying functions, which in this case, what we're going to go ahead and do is make a minor change to our functions infrastructure. We don't need to get too carried away here, but I do just want to add one more resource. So we'll scroll basically anywhere in here, keeping in mind that Terraform doesn't really care about the order of the code because it will figure out the requirements, the sequence, the dependencies as it evaluates the content. So we'll just drop our new resource here. This is our OCI gateway that we can use to make our OCI functions available from the public internet. So with that, it's again auto-saved. We've made a quick change to the code for this stack. So I can go ahead and just save changes. That'll update the code that's being stored in the Resource Manager service. I can also go ahead and save changes and run the plan action to see what's going to happen when we apply these changes. Let's minimize this real quick. We'll come back to our stack, and you'll see that the plan has been accepted. It'll take just a few minutes to run through. And if everything looks good in the plan, we could, of course, go back into our code editor and simply right-click, save changes, and run apply. So this would give us the ability to basically just plug right into that Resource Manager service, make code changes as necessary right here within our development environment, and apply those changes with little additional effort.
All right, so coming back, let's take a look at the next integration point here. This is for OCI functions, as I mentioned. And here I have an application that's been built. Within the application, I have a function. So I'm going to create a function called Python hello world. We'll go through a quick demo here in a minute of all the different ways to create that function, whether you have existing code or you want to pull from the sample or maybe pull from an existing source code repository that's out there. But here you'll see we can deploy the function that once we configure it. The deployment will include, what registry, where do we want to store the container for that function, how much memory, what the timeout looks like, the name of the function, and then we'll deploy that. Once we deployed that, we can invoke the function, we can modify the function, all of that right within the code editor tool, again, without having to go out to something like the functions console or another development environment. So let's jump over back to the console and we'll take a look at that quick demo.
Now we'll jump back over to the console again, and this time we're going to roll into the functions plugin. Yeah, we'll go ahead and keep the function CLI open here. And we're just going to scroll down. You'll see under applications here, I have my sample FN app. We have the sample FN that was deployed via Terraform, another sample function that was here earlier. And just for fun, we can go ahead and invoke this function. You'll see it takes just a second or two. And voila, the standard hello world output here. One quick note, since we've got the OCI, the function CLI here as well, we can easily invoke functions just for testing purposes as well. And this would give us the ability to actually pass a message body in to be interpreted or handled by our function. So I'm just going to echo in a value for name. We'll invoke that same function, and you'll see here, instead of hello world, we get hello our amazing audience. So this allows us to pass in parameter values versus simply invoking with the standard payload. Now I want to create a new function just to show how that works. So I will create a function here. And it's going to give me a couple options here from template, from sample, or from code repository. And going back to the code repo mirroring we did earlier, I did mirror in some sample function code. So I want to go back and I want to pull that, and we'll use it as our sample here. For the name, we're just going to call this Python hello world. Put in the URL for our repository. It's going to go ahead and clone, so it's prompting us for a name and password. We'll give those here in just a moment. It's going to go ahead and clone the repository and then ask, do you want to add that cloned repository to the existing workspace or open it in a brand new workspace? I think for the ease of use, we'll just add it to the existing workspace. Just a quick note, when you're ready to deploy, commit the changes, push them to the remote branch. And there we go. So we have our Python hello world. It's going to pull in that code. We can take a quick look. There's our Python code. Make sure everything looks good there. We've got our functions YAML file. So let's go ahead and deploy this. When we start the deployment process, it's going to ask us a couple of questions here about where we want to store the container image. We want to confirm the application name, the function name, and then we will need to pass an auth token for the service to use to interact with the container registry. So let me fill this in really quick. Once we're all set here, we'll go ahead and click the deploy button. And we'll watch it. Here we go. It's going to build a new image. It's going to push this out to the container registry. And after just a minute or so, we should have our nifty new function up and running, ready to use. And there we go. Our function is deployed and ready to use.
All right, so last but not least, we've looked at the cloud-based IDEs. What if you're using VS Code today? You're more than happy to continue using that, but you do want to leverage some additional integration with the Oracle Cloud. There is actually a toolkit for VS Code that gives you the functionality like you saw in OCI Code Editor. So you can actually download, install this toolkit right through the modules in VS Code. Once that's been installed, you'll see that it looks and feels pretty much the same as the functionality in OCI Code Editor. And here you'll simply authenticate your user. So it'll prompt you to authenticate through a browser. It'll generate a delegation token that is passed into your VS Code session. And with that, you can access the different services that you are permitted to access based on your user's permissions. So, and just one more thing, there's a variety of tools available. Again, this is all just about making sure that folks are aware and are able to make educated decisions based on what works best for them. So another great example of kind of an amalgamation of tools here is using something like VirtualBox as an alternative to collect and store all of your tools and your configuration in a really easy and portable environment. And I'm going to pass it over to Lynn here. He's going to give us a quick demo of how he likes to configure VirtualBox for accessing OCI services and resources. So Lynn, I will pass the screen share to you, and let's take a look.
Thank you, Eli. As I mentioned before, I like to work separate necessarily from the systems. So if we take a look at where we are today with VirtualBox, we've got a pretty good orientation. This is actually Oracle Linux 8 running inside VirtualBox. You can see that I've allotted myself a little memory on my laptop, 4 processors, essentially 4 threads. That's 2 cores, half of my existing cores on my laptop. I've got it configured for 2 screens, but we're only going to show 1 active today. I have 3 different networks available to use, and the reason for that is between my ISP and Oracle's proxies, it takes this to have a reliable interface, not only with OCI, but also with the repositories for any upgrades, things like that type of thing. So that's basically where I am now. This is actually 7.0 on your VirtualBox. You see, I have it open, and I'm going to put it into full screen mode. And just for grins and giggles, and so you guys can see it, and I'm in my temp directory. What I'm going to show you is how to interface with OCI remotely using Oracle's OCI CLI. So I've set up some very basic commands in place, and we're going to look at some of those right now. No fancy editor, just just VI. And so you can see the pattern for OCI CLI is the OCI, then a set of commands. You do have to download this from Python. It's a Python library that's available. So you have to be at Python 3.6 or so, and you have to download OCI CLI's package for that. But once you do that, the other trick is, and it will walk you through this, is to create the configuration file that you need to interact with your tenancy. So inside that, you'll have your configuration, which is text, and then you'll see you have the different keys that are required as well. And the configuration is an interesting thing that's useful, especially with your auth, because you can set this to the way you want to. Excuse me. Oh, that's right. You can set this to multiple locations. So you can set your configuration such that you can go to be different user, a different footprint, a different tenancy, compartment. But this is the real thing, to go into as a respective region. So you go from one to the other. And the rest of this is just a requirement that for security. So you're already signed in effectively. And when you go through this, you can use it in an interactive mode, which I think is pretty cool. It's a great way to learn, by the way. So you're on your machine, you're in a VirtualBox. You can experiment with different commands. For example, you saw compute, and then list. Excuse me. Image or instance. Yeah, image or instance. And then list. And then you have to put the compartment ID. And then I happen to know these are the compartments that are available in my tenancy. It's way too many, but so you say LML Lewis. So that is a one way to access the system. I instead now I don't want to take too much time. So with that as a demonstration of how you would particularly use it, and with your interactive mode, let's look at some just a script that I put in place. What this does, a series of commands, say, just walk you through it. So this compute an update of a particular instance ID, and this is where I've already downloaded and copied off of the UI what that instance is. So in this case, again, I can look at what the compartment based upon the variable C is the compartment ID, and that's pretty much a standard if you see in all the documentation to do that. The other thing to have is the tenancy in place. And then the thing about it is you can list both the both the instances themselves, or you can list the VNICs. So you can actually go down and crack out the VNICs as well. The other thing to learn with respect to this is the JQ-R type of for your JavaScripts, because this will return a very dense Java file, and you want to edit out what you're not interested in and to put what you are interested in. This little sequence of finds this data that is public IP address and lists out all the IP addresses for this particular, for the VNICs in that compartment. So that's the structure of this. And the other thing you can do is start and stop remotely these systems as well. So once you have the ID, the instance ID down, which you obtain by going through the compartment and then have it list out. So you could script all of this out for a start and stop every day to get your systems to work the way you want to. With that, I'll turn this back over to Eli to finish.
Awesome. Thanks for that, Lynn. Yeah, the CLI interactive mode is pretty cool because it, like you showed there, you don't have to memorize necessarily the compartment IDs and whatnot. It'll prompt you to kind of auto-complete the command, and it does simplify the process a bit along the way. So very cool stuff. Appreciate you sharing that with us. That brings us to the end here. So hopefully we were able to reinforce the importance and the value of source code management. Now everybody should understand how easily it is to access your cloud resources with the OCI Cloud Shell, along with your source code. Learn hopefully how to utilize some of the common development environments, whether that's VS Code or the OCI code editor. And then you saw here how easy it is to create, store, and execute code in the Oracle Cloud. If you have any questions, please do reach out. You can catch us on Slack. We've got a whole host of tutorials and demo content if you browse on over to developer.oracle.com and check it out there. And plenty more. Sign up for a free tier account. If you don't already have one, start experimenting and get to know the Oracle Cloud a little bit better.
So one of the things was referenced, I'm back in my VirtualBox, but the purpose of this is to show you some of the available tools. And for example, in your reference architectures, there's deploy GitOps with Argo control in Oracle container engines, for example. So there's a lot of different things here. There are other places you can find information is in your GitHub under Oracle repositories. So we've got a lot of repositories, a lot of examples that are available for you in those circumstances. I just wanted to validate that was in place, and that's what the output is supposed to look like. I had edited something, and now, so you can see it lists out the tenancy, the compartment, an autonomous database, a volume, a bucket, It shows you the IP addresses and the names of two instances, one being a ARM, one being an x86, and then it shows you a couple of VNICs and what the instance types they are. They correlate. In any case, I wanted to make sure you had seen that, and also, more importantly, saw the other resources that are available to you on OCI's web pages and in GitHub.
If you haven't already, go ahead and sign up for a free trial account. Comes with a whole bunch of resources, $300 in credit, and a host of always free resources that you can use to play with as long as you want. And the QR code there on the right, if you want to check that out, we have a whole another list of upcoming events. So hopefully you'll join us for future sessions. Renu, I'll pass it back to you.
Thank you. Thanks, Eli and Len. Great presentation. I hope everyone enjoyed the session and learned something new today. Our next webinar will be on Monday, March 4th, where you'll learn about Oracle Container Engine for Kubernetes. Join us if you want to learn how to deploy and manage containerized workloads at scale in OCI. I recommend that you bookmark the Devon and Beyond page and check frequently for new sessions on trending topics. And with that, thanks again for joining us. See you all next time. Have a great day, everyone.
Thanks, everyone. We'll see you next time.